Hi everyone, this is Jeremy Yang. I'm a research scientist at the University of New Mexico, Translational Informatics Division, led by Chief Tudor Oprea. And this is my UNM Tech Days 2020 presentation. Thanks to the Chief Information Officer, Dwayne Arudi, and his team for organizing Tech Days and its predecessors in past years, which have been great events for sharing and doing a little show and tell with enabling IT. I won't explain anything on my cover slide here, but I hope that the presentation will speak for itself and explain everything on this title slide. The motivation here is that our group, the Translational Informatics Division, is involved in something called the Eliminating the Druggable Genome Project, funded by the National Institutes of Health. We do informatics research across the translational spectrum, which means from bench to bedside and from molecules to medicine. We deliver scientific research products to collaborators at UNM, the IDG Consortium, the NIH, and community at large. These research products could be experimental or computed data, computational tools, some methodology, or combinations thereof. And delivering these products reliably, effectively, efficiently, and sustainably requires appropriate use of modern enabling IT and software engineering. In other words, we're scientists and we try to do science, but in order to deliver that to the NIH, which is of course serving the US taxpayers, we need to use modern IT and all those tools to deliver our scientific products. So this presentation summarizes one example of delivering science with powerful enabling IT. DrugCentral has a big story behind it, but briefly, it's a database of approved drugs, active pharmaceutical ingredients, which are the ingredients of the drugs, which are the active molecules, clinical products, as would be prescribed by a clinician, with indications, side effects, molecular mechanism of action, biomolecular targets within the human body, and much more. You can find it at drugcentral.org. And the next slide is the landing page of DrugCentral, which you can go to, and it's been up for some time now, several years. So what did we do for this small project? We built a Docker container. If you're not familiar with Docker, I'm not going to describe it. That's out of scope here, but I hope even if you're not familiar with Docker, you get a sense of what it can do through this brief presentation. Built a Docker container based on Ubuntu with the Postgres 10 database engine inside it, loaded that database with DrugCentral, that is to say the database which backs up DrugCentral. This is what can be referred to in modern times as the basis for a microservice. We uploaded the UNM Transinfo DrugCentralDb Docker image to the repository Docker Hub, which is the standard community repository for Docker images. We deployed this via Amazon Web Services, Elastic Cloud Computing, EC2, and this approach provides certain kinds of basic and strong security, although I should mention the most important security measure here is the fact that we have no sensitive data, certainly no HIPAA data. The data itself is completely publicly available, and so that's the foremost security. But in addition to that, deploying on an Amazon server provides some very nice security aspects because you're simply not opening yourself up to any kind of side effects or collateral damage. I developed a Python package called BioClients. It's available via the Python package index pypy, which means it's available from the command pip install for Python users. Within BioClients, which has several modules, there is a module DrugCentral for accessing a Postgres instance of the DrugCentral database. All these workflows are shared via GitHub as a source code repository. So in summary, DrugCentral has a public API now, available for a variety of uses, including cloning of in-house instances, as might be of interest to a commercial drug company that doesn't like to publicize their research interests for competitive purposes. So here's the schematic of what I just said. The innermost box, blue box there, represents the Docker container with Ubuntu, Postgres, and the DrugCentral database inside it. It talks on port 5432, which is the standard Postgres port. To work, that container has to be running inside a Docker server, which is represented by the middle blue box. That Docker server can run that container and map one port to another. So it's mapping 5432 to 5433 and exposing that. That Docker server is running inside an Amazon EC2 instance, which is represented by the outermost box. That appears to the internet as just another Linux server available via public IP. That same port is being exposed by that server and accessible by the two users represented on the left. One of those users is using BioClients, that Python package installed on their computer. The other one says, I don't need BioClients, and perhaps has their own Postgres client. And of course, there are many ways to access the Postgres database. A couple of the places to find these resources. This is the Docker Hub page for this image, the serialization of this container, DrugCentralDb. And once Docker is installed, you can pull that down from the repository with a Docker pull command. On the top is the Python package index page for BioClients. And then at the bottom is the GitHub source code repository for that same package. Since this thing is only, a few days old and a bit on the beta side, I would recommend at this point to use the source code repository, since things may be changing fast, as it says on the README. Now just a little pseudo demo, not a live demo, but these are commands and outputs from some of the steps mentioned. This is command line copy paste from the Amazon instance. So from this fresh Amazon instance, we pull down the image into a Docker server with the Docker pull command. Then we just make sure it's still there with Docker image ls. Then the third command, we run the container from the image, loading it as a container, then running it, and specifying at the bottom, you might notice restart always, which means that if the Docker server has to restart, or maybe the instance has to be restarted, the container automatically restarts, which is a nice kind of recovery mechanism, which should reduce your maintenance load. Here's a demonstration of accessing this running container and database from the standard command line Postgres client, psql. So not using BioClients, but simply using psql, we can connect to the database via port 5433 and list the tables in the database with the \d command from the psql prompt. And there's a partial listing here. I'm not showing you the full host address because we're in beta and not quite ready to go fully public, but to those interested, we may be able to share. Now, how about using the BioClients Python package? So after it's installed, it can be accessed in this fashion and others, but from the command line, you can run the module and various clients, the DrugCentral client thus, The -H gives you some help and describes some of the things that can be done. You can do things like get structure, get product, list structure, list product, and we'll do a couple things now in these commands. We're asking for 2 drugs by some synonyms. So the 2 drugs are accessed through synonyms Tamiflu, an antiviral, and Zantac, a drug for acid reduction, I suppose, stomach acid. Anyway, you can look up these drug structures using the get structure by synonym command, and notice that Tamiflu is found, and DrugCentral says that the structure name is oseltamivir. Similarly, Zantac is identified as ranitidine. So these are more the preferred or standard names for these drugs, although drugs tend to have many names. Next little demo, let's take one of those drugs, Tamiflu, and use the command get structure, meaning information about this drug compound as a chemical entity. And so some of that information is here, not all. And one thing that is there, which is highlighted by the yellow box, is what we call the SMILES, which stands for Simplified Molecular Input Line Entry System. That is actually a line notation which represents the atoms and bonds of that molecular graph. So by algorithm, we can convert that line notation into the structural depiction in the white box, which is what a chemist might want to see to understand what is actually there. So that's a little demo, or an illustration of a demo of what we're talking about. Finally, what is this really about? Just the idea that modern industry standard IT can enable sharing and sustainability of scientific research products in accordance with NIH resource sharing and sustainability principles. In other words, delivering what we paid for as taxpayers to the scientific community so it can provide benefits to medical science, public health, and the community at large. Cloud-based code sharing and deployment via Docker containerization are powerful, effective, practical, and perhaps increasingly necessary to play nice in our modern computing environments. There is a potential next level. If we were going to scale up, say we were going to form a startup company and imagine hundreds of thousands or millions of users, we would want some more elasticity in our deployment and not just a single micro instance. So what could be done is container management, also known as orchestration, via systems like Elastic Container Services, ECS, Elastic Kubernetes Services, EKS, and Elastic Container Repository, ECR. That would provide additional automation whereby I, as the sysadmin, am not responsible for making sure the Docker server is running, but ECS is actually responsible for that. If somehow the database crashes and that microservice shuts down, the container service recognizes that and restarts the container. So I have not done that, but that would be natural and what containerization is partly about. So automated recovery and load-based scaling. An actual next step is we're going to release a new version of DrugCentral this year with updated content and features. And so most likely what I'm describing will be part of that suite of tools and databases. So thanks very much, and feel free to contact me if you're interested in some additional information or perhaps even collaborative opportunities. Bye now.